Hello students, I have told you about the rectification of the AC and what the output is obtained, that is the fluctuating, because the direction is not changing but the amplitude is changing. So we are not getting the DC of constant amplitude. So just to obtain it, we want to have the constant DC output. So for this, there are certain when we are getting the pulsating or the fluctuating this output, then this is the mixture of the two components, AC and DC. And from this, if we however could filter the AC components or we can stop them, then only DC components will be obtained in the output. So that will be the constant amplitude of the DC. So for this purpose, the filter circuits are used. Smooth filter circuit. The output obtained in rectification is not of constant amplitude, but it is pulsating output. So pulsating is what that we are getting this is 0, this is now V0, then this is this time t, and we are getting the like this. This is the fluctuating or the pulsating. It's not of constant amplitude but is pulsating. So we want to find out the constant amplitude. To obtain DC output of constant amplitude, the filter circuits are used. The pulsating output is the mixture of AC and DC components. AC and DC components. A filter circuit filter circuit stops the AC components and allows to pass only DC components. Thus, the output from filter circuit is of constant amplitude. So in filter circuit what we have that the filter circuit has two elements, namely inductor and capacitor. So this is like this. Here and then here we obtain this is RL, this is L, this is C. This is the output from rectifier. Output from rectifier. So here we are having this like to this one, there we are having to this. This is now 0, this is V0, this is now time t. And here we are getting the outputs. Outputs. This is suppose your X and this is now your Y. So across to this X and Y. So this is in series and this capacitor is in parallel with the load resistance. The inductor is in series while capacitor is in parallel to load resistance. Is in series and while the capacitor is in parallel to the load resistance. So this only is the filter circuit. So now how does it work? That can be understood with the help of the inductive reactance XL equal to omega L, and this is equal to 2 pi FL, where this F equal to frequency and L coefficient of self-induction, coefficient of self-induction. This is equal to XL. This is what the resistance. Similarly, the capacitive reactance, XC is equal to 1 upon omega C. This is equal to 1 upon 2 pi FC. So now you see that here this XL directly proportional to the frequency, and here XC is inversely proportional to the frequency. Now in this output we are having the two components, AC and DC. So now we have to take for DC component. For DC component, F equal to 0. F equal to 0, so X equal to 0 and XC equal to infinity. It means that this inductor will behave as a conductor and this XC will behave like a insulator. It means that DC component will pass through this inductor, but it cannot pass through the capacitance. And for AC, component F is not equal to 0, so XL is not equal to 0 and XC is very small. Because we put the value of here, then the XC will come out to be less. It means what? That this capacitor will allow to pass only the AC component. So for AC this behaves like a conductor and this behaves like a insulator, because it is having the resistance to be very high. It means the inductor behaves as conductor and capacitor as bad conductor. Bad conductor for DC component. And for AC components, inductor is like a bad conductor. And capacitor behaves as conductor. So this is what the opposite. So the DC component passes through inductor. Passes through inductor and it does not pass through capacitor. Through capacitor. The DC AC components AC component cannot go through inductor, but it can go through capacitor. Thus AC components are stopped and DC components goes to load resistance where output is obtained. So this shows if suppose even there is the pulsating output from the filter, then a next filter circuit is applied. If output from one filter circuit is pulsating, another filter circuit is connected. in series to first filter circuit. If the output from one filter circuit is pulsating, another filter circuit is connected in series to the first filter circuit, and finally the output DC components will be of constant amplitude. So at last we get this is now this, then we are getting this is the V naught. This is now time t. So this is DC component, and now it's this amplitude is constant, so we are getting a DC component of constant amplitude. So this is all about the filter circuits. So actually that what the output is obtained from the rectifier is not perfectly DC. So just it is the mixture of AC and DC components, and so it is needed the filter circuit to stop the AC components and to allow only the DC components. So thus at last when from one filter circuit the output is again something pulsating, then we add the next filter circuit. If from the next one we are again getting the pulsating, then we add the next filter circuit. So thus a series of filter circuit can be used for obtaining the DC output of constant amplitude. So this is how the this filter circuit works when it is applied to a pulsating current, a pulsating output. So you all like and subscribe this video, and also I tell you that your online classes are being started by me on the June 1st, 2001. So you all may contact on your phone number online classes. From June 1st, 2001. Contact number 7014734805. So you may contact and register yourself so that you could join the online classes. And also the crash course of physics for NEET 2021 will be started on the same date. So please contact and get your registration. Thank you very much.